Welcome, everybody. This is G2G Dallas, and we are now ready for our feature presentation, a presentation entitled gRPC with Kotlin Coroutines on Android by Mohit Sarvaiya. It's probably
That's right.
It's
Sarvaiya.
close. It's close. Sarvaiya. Mohit Sarvaiya is a Google developer expert for Kotlin, and over the years, he has talked in various communities around the globe and has helped many companies adopt Kotlin and coroutines. Take it away, Mohit.
All right, thank you. So my presentation is about how to use gRPC on Android. Before I begin, are all of you Android engineers or are familiar with Android development? Well, that's good. That's good to know. I'll go more in depth as I present. So what I'll talk about is, so I use gRPC and I'll share my experience and I'll talk about common things that you would, do when you use gRPC, like authentication, how do you handle retry, how do you do debugging? But we should start off with what is gRPC. So gRPC is a way to send messages from your app, from your client side, not just your Android app, could be an iOS app or a web app to backend. And what you could do with gRPC, what makes it really powerful is that you could open up different types of connections, streaming connections, stream data. So you could open up a connection, send one message after another. It could be for any type of use case. And it's a framework that was created by Google, and you could implement it in different languages: Swift, Kotlin, Java, etc. So let me describe to you, the typical setup that you would have when you use gRPC. So this is a polyglot implementation, meaning it supports different platforms. And also recently, like last year, they added coroutine support that I'll go through. So when you're building an Android app or any type of application, it communicates with some type of a server. And usually, you have different languages that all these platforms use: Kotlin, Swift, or your server code might be written in Go, or maybe it's also written in Kotlin. So the way with gRPC is that on the server side, you define a file called a service. And what's inside of that file? What's in there is all the types of requests that you could make to the server, RPC requests, RPC calls. It defines all the messages that you could send and receive. So the server gives you a contract. They make this contract in this file. And this is what it looks like, example of a file. So over here, I have a service and I have a call that I could make. The client could make a call called subscribe, and they could send some message to it. And it defines what messages you could send and what you could get back. So the server defines this contract. Then what happens is that, so what's inside of that contract are these are the different types of calls you can make, and they all have different benefits, and I'll go through each one of them. And these streaming types of calls that you can make are what makes gRPC powerful. So the way this works is that the server defines the contract, and then the clients each have a copy of it. They each have a copy of the same exact, service file. And on the client side, what happens is that from this contract, the service file, you generate code that is utilized to actually make the RPC request. So what happens is that on the Android app, it takes this service, and this service is written in something called protocol buffers, which is a way to format. It's kind of like, it's a way to format, what RPC calls, what messages, and what's inside those messages. It's a way to specify that. And so when you build your app, you're using this, you have this file locally in your app. And what you have to do is that include something called a protocol buffer Gradle plugin. That plugin, you specify where does this file live in your app. So it grabs that, basically gives it to a protocol buffer compiler, and it generates code. And this code, it's basically what it generates is a client. And the client, what it has is all the machinery. It knows all the logic to know how to make an RPC request. It has all the lower level logic, and you're ready to use basically that client in your app to make actual RPC calls. So I will show you how this translation happens. How does it translate the RPC calls into actual code? So this generated client has basically, it's a class which has a function, a method for each type of RPC calls. And the messages that you send to it, they also get converted into a type, so that you could utilize. So when you make a request using gRPC, it uses HTTP2 version 2, and it uses HTTP2. That has consequences, in terms of, like, for example, you make this connection. When you go to Android Studio monitoring tool, you probably can't see this HTTP2 call, connection and what is being sent. And so you're sending messages back and forth. So this is the setup that you have, client and server setup, and we're using gRPC. So let's look at a use case, a simple use case where we're building an app that uses gRPC and all these different types of connections. So what we want to do is use Kotlin coroutines to build an Android app. So let's look at a use case. So this is the library that we're going to use. This is the library that was released about last year. And what's special about it is that what this does is that it will use coroutines. So it will use flows, to be able to make those streaming calls, which I'll show you how that works. So how do you do this? So let's look at a use case. Suppose we want to build an app that, tracks, for example, like your scenic route or any type of route that you might take. Well, suppose that you're driving and you want to build an app like that, where you could check into places, for example, and explore what's around you, like a location-based app. So this app could track your route. It could also, you click on the map and you click on a specific, red arrow, and you could determine what's at that location. If given a latitude and longitude, tell me if there's a restaurant or some type of, give me information about what place is there. You can also list places around a specific location that may have been an interest to you. And you could also chat with other people at that specific location. So I chose this use case. This is a location-based app because each of these different types of features you can implement using RPC calls, gRPC. Using different types of gRPC calls, and I'll go through each one of them. So when the server gives you, when the server will define what type of RPC calls you could make. And let's look at how the server would define this contract for this use case. And we're going to use protocol buffers, which is library by Google. It's a way to format, like data interchange format. So in order to define in the contract, the first thing that you'll see is that you'll see what version of protocol buffers you're using. And there are new features in each version. Version 2, version 3 has new features. They also provide backwards compatibility. And so the next thing you'll see is that you'll see the keyword service, and you'll see the name of your service, which is called places. If you're familiar with retrofit, it's similar to that. So let's look at how you would define something called a unary call. And a unary call, we're going to use it for this use case. Suppose that I told the server my current location. I want it to tell me what is the place at this location. And to implement to specify that, so I'm going to have the client, the Android app, give the latitude, longitude, or where you are. and the server gives me what place is there. So in order to define that, every RPC call begins with the RPC keyword, and you give it the name, just as you would with a method. But the convention that's followed is that, the first letter is always capital. So I want to get a specific place, and I specify the client will give a location. So this is a particular message. And then I say returns, and the server give me a response, which is a certain place. So in here, you can see inside of those curly braces, you're not defining like an actual method in there. You're just specifying like in this format, and in this way, what's going to be given to it and what's going to be returned by it. So this is called a unary RPC call. And basically with unary RPC calls, you basically give it something, and then server gives you something back. The server doesn't stream data back to you with this type of RPC call. It's just that here's a request, give me a response, just similar to like a get request. So now what we need to do is define what does location mean and what does place type mean. And using protocol buffers, we could define what messages are going to be sent and received. So there's a message keyword. And then I have the name of my message, in this case, a location. And then you define what's going to be part of this location. So this maps to a class, right? You can see the fields. So you specify fields in there that are part of this message. So one thing to note is that you'll see the numbers like 1, 2, in each field you add, you increment the numbers. You also see that there are types here. There's a double, and protocol buffers supports different types like int, double, float, string. So you'll see that on the website, protocol buffer, documentation, they provide you with this mapping. So if I were to use an int, 32, what does it map to in Java or some other language, C++? So that's, these are all scalar types of values. So the next thing that you want to do is specify the place message. The place message, the way inside of it, you're going to have what is the name of the place at that location and the location data itself. So you could, in your message, you could reference existing messages that you already defined. That's what I'm doing here. And then you could also specify an enums in your messages. So this is a particular type of place, right? Place type is an enum. So it could be like a landmark or a restaurant, a retail store, etc. So this is how you specify enums, and they map to enums in whatever language you're using. So lastly, something else that you could specify are, suppose that you at a particular place, you could see how many people reviewed it. So you have, I'm specifying that using this in scalar value. So what I've done so far is specify the message that I'm going to send and the message that I'm going to receive inside of this service contract. So on back end, you'll see the service contract specified. So this is a unary RPC call. So now the other thing that you could, that protobuf gives you is that protobuf library has like built-in types of messages. Suppose that like someone checks into a place, they do some action on the app, particular retail store check-in, but I want the server, when they check in for that request, to give me an empty response. So that you could do that. And let's look at how you do that. So the client gives latitude, longitude, location, and the server gives an empty response. So similar to how we did before, we have an RPC call here called check-in, giving it the location, and then what it returns, I'm going to utilize, this is in the protobuf library. So you'll see in the protobuf library there are built-in messages, and this is one of them, empty. And there are also other types of built-in messages that you could import and use. So you could think of it like this library has existing like proto files that you could reuse. And it has, like things that you could use like timestamp and duration, for example, all those different types of things. So in order to use one of these built-in like prototypes, I basically import it like this, and then I specify that I want to return an empty response when someone calls this, makes this RPC call. So that's how a unary RPC how is defined. But what makes gRPC powerful and why a lot of people use it is due to this capability to stream data. Like suppose like you're building something like like a Slack, an app where like a Slack channel. When you think about that, you have people, messages could be coming in and you can send replies. You're streaming basically those comments and messages. How do you build that? You could build that using gRPC, a chat application, for example. So let's look at server-side streaming and what that means.
I'm sorry, Miss Sir. I have like a question.
Oh, sure.
I'm sorry.
No problem.
But what you're saying is that, say for instance, I'm the end user using the app. Yeah. And I have a question or something like that. Someone can be on the other end basically answering the question. Like, is that what you're saying?
Yeah. So if you, for example, like we're in this Zoom, meeting, we have a chat feature. So I could send some message in the chat and anyone could reply to it. So to build that, for example, we could, implement that, we could use one of these streaming. This would be bidirectional streaming for that example. So yeah, for that use case, using one of these streaming calls fits well to build it.
Okay. Okay, thank you.
Yeah, so and if anyone has questions, feel free to ask me along the way. So one of the is, suppose we have a use case where I give to the server an area, right? An area on the map. And then I want the server to give me a stream of all the places that are located in this area, in this red area. So I could implement that using server-side streaming. And the way, how do you specify that in this service file, in this using protocol buffers? So I'm going to give it a location, or not just one, but a couple of them, to define an area. It gives me a stream, right? And it gives me the server could give me these items at any time, not just at equally spaced intervals. So here's an example of how you specify a server streaming RPC call. So this looks exactly like it did before, like a unary RPC call, but the difference is, there's a difference here. So first, I'm giving it the new type called area, which I give it 2 locations, like, give me all the places within these 2 locations. And then what the server gives me back is a stream. So in order to specify a response from the server should be a stream, I'm going to use the stream keyword, which is easy to understand, like, and that's how you specify, that a certain response will be streaming. So this is how a server streaming RPC call looks like, how you specify that. The other type of RPC call is the client-side streaming. So in this case, rather than having the server give me a stream of data, like having an open connection, the client could have an open connection and give a stream of data, and the server could just, wait, and after it has gotten everything from the Android app, just give you a response back. An example of this is that, suppose that you're walking and you basically could check into multiple places, and I want to give it the server a stream of locations, and it could give you a summary of your route. So for example, so I could give, in this case, I'm not giving just one location, but a stream of locations at any particular time. And basically the client, the the server could wait until it has read everything, gives back a summary of your trip. So how do you implement that? And the way you could implement that, here's an example of it. So the difference here is that I have the stream keyword on the client in the argument of this method rather than the return type. And that's what makes it client-side streaming. So this is an example of client-side streaming, how you specify that. The next most powerful thing is streaming both on client and the server. And with that, you could build, for example, a chat application of some sort. So suppose I want to build something similar to this. So how do you implement this? So I could send in a comments. I could send like to this stream, like at any time I could send like a message, a comment. Someone could reply to that at any time. And so the way that works is that in the bidirectional stream, this is an example of it. And I have specified the stream keyword on both sides, the argument and the response. So these are the different types of RPC calls that you could make. And with the, and this is how you specify them using protocol buffers. And what makes RPC powerful is the service streaming type of RPC calls. So once you have this, the server, the implement has this contract, right? You agree with the server people, and that this is what messages will be sent, what will be received, what RPC calls you can make. So now you need to consume this in your Android app. And the way that works is that, now let's look at how do you consume this? Like, how is the client stub built? So you will take this in your application, this service, this file, protocol buffer file, you put it in your Android app, and you use the protocol buffer Gradle plugin. And this, you configure that plugin, there's a way to do that. And what the plugin does, basically takes that and it generates for each type of message, for each type of the service, generates code from it. So in the code, let's look at, what it generates and how the coroutine code looks like for each of these RPC calls. That's where the interesting part comes in. So when it looks at the message, like a location, it gets converted to Java code. So this is it creates a builder, for example, on the client side, when I, send an issue to add the support in there. So that's one of the drawbacks. So you could also, rather than using the protocol for Gradle plugin, you could also use the Kotlin serialization plugin also. And I believe that does generate Kotlin classes. So you have different, different ways you could go about creating a client stub. So let's look at how the service, how each RPC call translates into a particular code using coroutines. So it generates a coroutine stub like this at build time. So what it does is that it takes, for example, this is our urinary RPC call. How does this get translated in using coroutines? So the way it basically creates a suspending method. So, on Android now and in Kotlin, coroutines were introduced a couple of years ago. And they have come a long way since then. And suspending, the way coroutines works is that you create a scope and you call it a suspending method. When you call it, the coroutine will suspend until there's some result given back to you. I'll show you how that works. So this RPC call, right, when it's made, it will suspend until a response is given back, which is a particular place type. So the next thing is that how is this right here? This is a server-side streaming call. Well, this is where things get interesting and why this library is really useful. And basically what it does is that it translates this into a function that returns a flow. A flow represents a cold stream of data. And it's part of the coroutines library. So when you could, and I'll show you how to, read from this stream of data, read from this flow. So it translates this into a flow of places. So on the client side streaming call, it translates, this into a method in which takes in a flow. And this is a bidirectional streaming call. And it takes in a flow and also gives you back a flow of data. So this is what makes it powerful RPC. So that's how all these different RPC calls are translated into these different methods using coroutines flows. And once this code is generated, the next step is how do you use this client to actually make an RPC call in an Android app. So there are 3 steps to this. So one is to create something called a channel. And in the channel, you specify, what is the URL of the server and the port that I'm hitting. And then you give this channel, once you set it up, to your generated client so that it knows, what server URL that you're going to communicate with. So in order to create this channel, there are different ways to do it. There is something also called the OKHTTP, channel that you could use. There you could there's also one specific for Android that listens to the network state. So it helps you, it handles, shutting down or reconnecting, when based on your network state. So there are different types of channels. And you give in this channel builder, you give it what host and port. You could also use HTTPS TLS using transport security. Just like in OKHTTP, you could set up interceptors. So once an RPC call is made, like this method here, this interceptor gets called, and you could do anything that you want in there, logging, monitoring, etc. So the next thing that you could do, and you create this managed channel. Once you have it, you're going to give it to this generated coroutine stub, and now you're ready to basically use this client in your application. So those are the steps to set up and use gRPC in your app. So how do you now use it in your application? So suppose like you're building an Android app and you're using, for example, suppose you're using MVVM, model view model approach. And usually, when that approach, you have a view model. So the Android ecosystem provides a view model class for you, and it handles configuration changes, etc., that you could utilize. And you could give to this view model this generated client stub to make calls in it. So suppose you created this view model. There's an example of it, and I'm injecting it my coroutine stub, my client. And in there, what I suppose I wanted to make a call, this urinary call, give it a location and return me the place. So the way with coroutines, you need to specify a scope. And the great thing is in the Android ecosystem that there's a view model scope which is given to you. And the great thing is that view model scope, the way you could look underneath the hood, the way it's created is that it handles like lifecycle changes. It handles tearing down when the activity is destroyed, and etc. So what I'm doing here is that I'm launching a coroutine on this view model scope. And inside of this coroutine, what I'm going to do is that I'm going to basically tell my client, make the urinary call. So when get place method is called, it's a suspending method, this coroutine will suspend, and then I'm going to get a response back that I could process. So sometimes you may want to do this on a separate dispatcher. You could also specify which dispatcher to run this coroutine on. IO, like default, etc. So the other type of RPC call that you can make is the one that returns a flow. So how do you read from the flow in your view model? So the way you could do that is that I'm going to create a coroutine on my scope as that I did before. And then I'm going to tell the client, give me a flow that's just doing here, and I could collect from it. So what's powerful about this is that one of the things is that I could use like map, flat map, all those types of operators on this flow, and to make things, which makes it much more functional. I could also specify that I want to read from this flow in a different thread, like different dispatcher. I could also do that. So collect is an extension on the flow, and what's purpose is to allow me to read from it, collect from it, or read from the stream. And the other type of RPC call, which is bidirectional, is a bit more complicated. So suppose that you're building a chat application and you want to have a stream, basically you're sending to this RPC call, and you are also reading from it. And how do you specify that? So in order to specify that, one way you could architect it is that there is now something called a state flow. So in coroutines library, there also are this concept of channels similar to, for example, in RxJava, like a subject. You could like push things to it, and you could also read from it. So in coroutines now, library, it provides you with two constructs, which are mutable state flow. You could send things to the mutable state flow and listens to it. There's also mutable shared flow, where you could listen to that also. And both of them have different features. So I could set up a state flow that I'm pushing things to, like you type something in, you enter it. I'm going to push your comment, your whatever message you have to this construct called a state flow. And then I have a subscriber that's reading from the state flow and giving it to this RPC, making the RPC call, taking what you type in and then giving it to the RPC call. And then, the server gets it, and then you could get a response. So the way you could set that up is that you have this method of flow of comments. I launch a coroutine from there. I tell my client, here's the basically stream of comments that I want you to give as part of the request, and I'm also reading from it. So this is a very, very simple setup of of using a bidirectional streaming call. So this is how you would implement, consume that client in your view model and in your Android application. So now let's look at, how are coroutines used inside of that client. So what we learned so far is how protocol buffers work, how to specify a service with them. We learned about how basically what does it get translated to using coroutines. So the library, how does it work underneath the hood? So the gRPC Kotlin library, there's also a gRPC Java library that exists before gRPC Kotlin library came out. And the Kotlin library builds on top of that Java library. It builds on top of it. It's a dependency internally to it. And how does the generated code look underneath the hood? How does it use coroutines? So underneath the hood, what you'll see is that it creates a flow. And inside of that flow, there's two coroutines. There's one coroutine, which is listening to everything that you're giving it. It give you every request you make. Basically, there's this coroutine that's running and taking in basically the requests that you made. It also starts this client, to give requests to. And it uses in gRPC, the Java library, you have an API that's given to you, which specify how to start the client or send messages to it, etc. So inside of there, there's another coroutine which takes the message and then gets a response. And the response, whatever that comes back, is given to a particular channel. And the channel is similar to a subject, like in RxJava. And what happens is that this whole flow, this whole setup is exposed to you as a flow. So for example, as soon as I, over here in this example, as soon as I call collect on the stream, this setup right here will start. Basically, it will come into play. It will execute this code of these two coroutines, basically working together to handle request and response. What's useful about this is that as you're debugging, you could set a breakpoint in here, you know, and see what's, sometimes you may not be getting a message and you expect it to. And you could set a breakpoints in here to help you to debug and figure out what's going on. So this is how it's set up underneath the hood in this generated client. So now let's look at authentication. Authentication, basically what it is that, you know, when you may use OAuth or some type of authentication, there are different ways to authenticate. How do you authenticate, you know, an RPC call in gRPC? And these are all different ways to go about it. And what I want to share with you is how to use a token. How do you authenticate via a token? So,
I'm sorry.
Sure.
So, to iterate, I guess, I guess the question would be, when developing the app, you use RPC or urinary, and of course the
bidirectional, yeah.
Yes, and basically, it'll let you know if something is going on with the app, if it's not functioning correctly.
So if so bidirectional call is one of the things that you could use, one of the RPC calls you can make. If you encounter like so in this flow, as you're using these RPC, making these RPC calls, like in the library, you could set, like, if something is not working properly, breakpoints, and as the RPC call is made, as the request comes back. And that was helpful for me to learn, to be able to debug in situations where there's some weird issue happening.
Okay.
Does that answer your question?
Yeah. So I was picturing. I'm sorry if I'm kind of caught up in words.
Oh, no
so
problem.
So basically, this is like the back end of how to make sure that your app is working correctly.
Yeah, it's more of a, it's kind of like knowledge of how the library works underneath the hood, just to, if you ever encounter any issues, or to, as you said, to make your app work correctly. Yes.
Okay, thank you.
No problem. So authentication, when you make an RPC call, you want to authenticate, and there are different ways to do that. So what I want to share is how do you authenticate via a token. And suppose when an RPC call is made, I could send metadata as part of it. So, and the server would read that metadata, receive it first, and I could send a token as part of that metadata to the server to do authentication. So I could create a metadata object like this. This is how you would send metadata to the server. Basically, you could add any type of token that you want in there. So metadata is part of the gRPC Kotlin library that it provides you. So I could set whatever type of metadata I want, not just token. And the way this works is that when I set up basically my stub, there's a method in there called with call credentials. And the way this works is that, so as the name says, I'm basically handling credentials with it. So in order to, what I give to this method is this, object. And this object in this, there's a method that is overridden, called apply request metadata. in which I'm going to specify basically, the metadata that I want to send, which in this case is a token. And I basically give it, calling this apply method. So this is the method that I would basically send some type of token as part of my RPC call for authentication. And using this with call credentials method on this when I go and create my stub. So the way that works is that when the RPC call is made, the metadata has the token and the server could do authentication with it. So lastly, how do you handle errors? You may want to do retries when a specific type of error happens. So errors are something which is really tricky with gRPC. When you make an RPC call, if I want to do a retry, there's an option, built-in option provided on the channel called enable retry. So the way this works is that I have my client app and I send an RPC request. And then the server, the way this works is that it retrieves it. And then if there is an error, it returns a status code, like whatever error it is, unavailable. There are different types of status codes. And the gRPC library gets it. Now, what happens is that if there is an error, there isn't a callback on you on the client side app. That's one of I found the drawbacks personally. So internally, when it basically handles this for you and it retries, there isn't a callback to tell you that there's a retry happening. That's one of the things I found. So, and when those retries succeed, you ultimately basically receive data message, or if there is a failure. You could set up how many retries you want to do. You could set up number of backoffs you want to do, number of seconds that you want to wait until retry is done, or on what type of error you want to do a retry on. You could set this up when you're setting up, your RPC call, when your gRPC. So the other thing is hedging. So when I make a call to the server, but I want to send out multiple calls and see which one succeeds the fastest. So I could do that. I could, this library gRPC has support for that. Suppose it will make a copy of those calls, and whichever succeeds, it will give me the result. Like canceling those ongoing calls that were made, the copies of them. So you could also set up, your hedging policy, like when you want to do that, if you want to set up a number of max attempts, etc. And you would basically you could create this like JSON in a particular file and then read it and give it to your channel. You could also create a map and give this configuration to it. So lastly, what debugging tools are there? There is a debugging tool called Bloom RPC that I found really helpful. And I'll show you a GIF of how that works. So here is an example. So what you do is that you take your Perl file and you give it to this tool. And when you do that, on the left, you'll see here is that it basically tells you what RPC calls you have, like get by ID, get by IDs. And when you call one of them, those are different RPC calls, and you could give it, for example, you could see your metadata. You could give it some, whatever your payload you're sending, and it returns you a result. So here I'm giving it the protocol buffer, and then I make the call and I get some result back. This is this right here, you'll see a streaming call right here. You see the streaming call. You see stream 1, 2, and 3. So if the server was sending you multiple like streams or requests, the reason why this is helpful is that like sometimes like this is like a playground, like in GraphQL, there's a playground. And this is something that was really helpful to me as I'm, learning about gRPC. So I wrote articles about this. I wrote an article, on gRPC. You could check out on my website. My website is codingwithmohit.com. And it has also wrote articles about how to use coroutines and how to handle delays. I have extensive experience using coroutines and also on backend. So I have worked on building a backend server with gRPC. So just share my learnings on my website based on my experience. And this is my article I wrote. Has everything that I shared with you in probably more and more detail. You could check out on my website, codingwithmohit.com. So the other thing I want to say is that I'm giving a presentation next week at the Chicago Kotlin meetup, which is on building microservices with Micronaut, which is a framework like Spring. And I'll share with you what benefits it has, and from my experience, how it works. And also, lastly, I want to say is that I enjoy teaching. If you want to learn about coroutines, if you want one-on-one training, or you want training for your team where you work, like a group of people, I could give. I'm happy to help in there, provide training, coroutine training on how to use it on either on Android or backend. So you can contact me on my Twitter handle, heyitsmohit.com, if you're interested, and it's free of charge. Who would provide that? Okay, so thank you so much. I never been to Dallas, but this is my first time presenting virtually. I'm virtually in Dallas. That's good. Thank you. And if you have any questions, yeah, just let me know.
Hey, it's Mohit. It's a great Twitter handle.
Thank you.
So, yeah, like we can open it up to questions and applause. Yes, thank you, David.
Congratulations, Mohit. You did great.
Thank you.
So I have one though. Was the gRPC, were you involved in that selection for the endpoints that you were working with when you were learning this?
Yes, I was.
So I know that there's a lot of other conversations, right, around gRPC versus GraphQL.
Right.
And I'm just kind of wondering, other than some of the space niceties, right? What pushed you towards gRPC declarations rather than the GraphQL formation style?
Well, I did not consider GraphQL when I started, but I know there is like there's GraphQL subscriptions, which I don't know in detail about, but similar, it allows you to set up streams. And so I had two options. One was, with REST API, like, emulate the streaming with doing polling. That's, one possibility. But, who wants to do polling? You just, who wants to do polling, like in a loop? And when you
shared flows and state flows are like super awesome, man.
right, yeah. And well, you still have to one of the challenge that coroutines library doesn't have they deprecated like a ticker, for example, like a flow that just gives you, and you'd have to build that yourself. So yeah, that's from my experience, one thing I found downside. So I went with gRPC. I did not consider GraphQL when in my learnings.
Okay, maybe that's all the questions we'll have for right now. We'll stay on a little later. I'm going to go ahead and stop the recording, but thank you so much, Mohit, for presenting this. It's very informative, and I think it'll be a great reference for people, even in the coming years, as you see, people kind of move into this more streaming, or they have a streaming, type, solution they're looking for, and this is going to be a great reference, I know, for a lot of people. So thank you so much, and
no problem.
Yeah, we look forward to next time.
Yeah, thank you a lot. I learned a lot from today. I was so excited.
No, thank you.